Assalamu alaikum warahmatullahi wabarakatuh. We are students at University Malaysia Perlis and we are studying mechanical engineering. And in this video we are going to talk about internal energy and enthalpy and specific heats of solids and liquids. And I'm going to start off by talking about internal energy, which we can define as the sum of all microscopic forms of energy. Now, what is the microscopic form of energy? The microscopic forms of energy is that which is related to the molecular structure of a system and the degree of the molecular activity, like sensible energy, latent energy, and chemical energy, and nuclear energy also. Now, usually we can use the capital letter U to indicate the internal energy, to express it in mathematical equations, and its unit will be kilojoule. We can express the internal energy by using the energy balance equation, which is En minus E out equals delta E of the system. En is obviously the energy going into a system, and E out is the energy coming out of the system. And the U actually comes up in the second equation, which is Q net minus W net equals total energy of the system equals the internal energy plus kinetic energy plus the potential energy. Okay, and the Q net here is the total heat that's coming into a system and coming out of it, and W indicates work. For the third equation, we actually simplified the second equation more because most of the times kinetic and potential energies can be neglected. So we can say that delta U equals Q net minus W net. Furthermore, we can simplify this equation to say that mass M multiplied by the final internal energy minus the initial one equals to Q net minus W net, which is...
Some people don't know about enthalpy. We want to define as enthalpy a thermodynamic quantity equivalent to the total heat content of system. It is equal to the internal energy of the system plus the product of pressure and volume. We use the letter H to indicate the enthalpy. The equation from enthalpy, H equal U plus PV. It has units kilojoule. If you want to indicate U meaning internal energy of the system, and P meaning pressure, and V meaning volume of the system.
We define the specific heat as the energy required to raise the temperature of the unit mass of substance by 1 degree as the volume is maintained constant. The specific heat at constant volume CV equal del U over del T. That's mean the change in internal energy with temperature at constant volume. Another specific heat, a constant pressure CV equal del H over del T. That's mean is the change in enthalpy with temperature at constant pressure. CV is always greater than CV. Why? Because CV include both PV as well as internal energy storage. However, CV include only internal energy storage.
The relationship between the internal energy and the enthalpy with the specific heat. We can see that the specific volume for solid and liquid essentially remain constant. So for that we can say that for liquid and solid they are an incompressible substance. Therefore we can drop the Cp and Cv and represent for the specific heat as a C, as you can see here, because the change in specific volume doesn't affect on the internal energy or the enthalpy, and we can find it at table A3. We can express this thing mathematically by an internal energy by du equal to integrate Cv dt. But as we said previously, Cv equal to Cp, so we can represent the Cv and Cp by C. So it will equal to C delta dt. After the integrate, it will give us delta U equal to C average delta T, and the unit will be kilojoule per kilogram. In enthalpy, there it will be a little bit different, because the enthalpy, it will equal to U plus BV. That means the internal energy plus the pressure times the volume. If we integrate it, it will be dH equal to du plus dBV equal to du plus VdP plus PdV. But as we said previously, that the volume, it will not affect on our enthalpy, so we can cross it, and the dH will equal to du plus VdP. Also, that we said previously that delta U equal to C average dt. So at the end, after we integrate the whole thing, it will give us that delta H equal to C average dt plus V delta P, and the unit will be kilojoule per kilogram. For liquid, it will be a little bit different, because we have two cases. If our case was constant pressure, the delta H will equal to delta U, so both of them will equal to C average times delta T. But if our case was constant temperature, that means that delta T equal to 0, so that delta U will be equal to 0, so that delta H will equal to V delta P.